So I've made yet another hot end. There it is. So this one's dedicated to multi-colour printing as opposed to multi-filament printing. So it's a bit more compact than other ones. So what we have, that's a complete assembly with its cooling solution and everything. So the brass bit is the hot bit, and the aluminium bit is the cooler block. So liquid coolant in, liquid coolant out. Four inputs on this one, because it's quite a bit more compact and shorter. I've had to make these plates to drop it down a bit in the carriage so it will still fit on the same kinematic mounts that I've used before. Any nozzle with a M6 by 1mm thread. So as I say, it's dedicated to colour printing. Now one of the issues with multiple input hot ends is just the volume of molten plastic that you have. It generally means you've got a lot of retraction. They're kind of prone to oozing as well. But one of the issues is when you've got a big volume of molten plastic, if you're trying to print fine detail, it kind of acts a bit like a giant sponge. So if you've got short, sharp filament moves going in, the volume of filament kind of absorbs those pulses, for want of a better word, and they don't translate to short, sharp pulses at the nozzle. It's a bit like a slow digital to analog converter. So you've got these pulses going in, but what comes out is a kind of a curve, a wavy line, slow moving wavy line, and that's kind of the effect that having a big volume of molten filament between the input and the output has. So what I wanted to do with this one is to reduce that volume as much as I could. So from going to 6 inputs to 4 inputs, that immediately saves 1/3 of the volume. So it's so this one's just got 4 inputs. So I could use, say, red, blue, yellow and white, and then although they would get combined rather than mixed, I could combine blue and yellow and get some sort of green, depending on literally how you look at it. Red and yellow would give orange, blue and red would give purple. If I start with dark colours and mix them with, say, white as the 4th filament, then you've got different shades of those colours. So for example, red and white gives pink and various shades of pink, albeit, as I say, still with the stripy toothpaste effect. So I've got some pictures of it which I'll pull up and then sort of talk about it a bit more. So the hot block, I've made it out of brass, just because it's easier to drill fine holes at compound angles. When you're drilling small holes with small drills in aluminium, it tends to sort of pick the swarf up, and then the drill can wander, and the holes don't always come out at the same point, which is what they need to do. So that's the main reason for using brass. Copper's just hard to come by and expensive. So as well as reducing the number of filaments, I increase the angle in the combining block so that they go at a bit steeper angle. So that's effectively reduced the filament path length from around 34mm in the 6 input one to around 25mm. So that's a further kind of reduction in volume. And then the other thing I've done is I've reduced the diameter of the holes. All my other hot ends have been 1.8mm from the filament input right through to the nozzle input. But this one, they only start at 1.8mm for about half the length or something like that, and then it reduces down to 1mm. I'm hoping that won't be too restrictive. I shouldn't have thought so, as I'm be printing with a 0.5 or 0.6mm nozzle, something like that. So it shouldn't be too bad. If it is, I can always drill them out again. But that makes a huge difference. I mean, the cross-sectional area of a 1.8mm diameter hole is about 2.5mm, whereas the cross-sectional area of a 1mm hole is around about 0.8mm. So in terms of area, that's it's about a third of the size. So I hadn't given it much thought before, but I did a bit of a spreadsheet and I calculated the volume of molten plastic that was inside the 6 input one with its shallow angles, long filament paths, 1.8mm diameter, and I was quite amazed that it came out at about 520 cubic millimeters of filament in total, of molten filament that is. So with reducing the number of inputs, making the hole smaller, making the filament path shorter by using steeper angle, then this one's about 166 cubic millimeters, which is about 32% of what the 6 input one was, or saving of around about 2/3 of the volume. So it should help. It should be a bit better for doing fine detail. It shouldn't need so much retraction and so forth. Then some other improvements I made are the heat breaks. Previously these were 6mm outside diameter with just a 3mm section reduced to 5mm with a 4mm bore through the middle to take 4mm PTFE. So what I've done with these, I've made them, it's a 4.1mm bore so that a 4mm tube will slide in quite easily, and the outside diameter is 4.9mm, so they'll slide nicely inside a 5mm diameter hole, which means that I've made them the entire length of those dimensions, so there isn't a short section where it's that thin. It's that thin all the way along, so that should help in the cooler block. So it should take away the heat. So the wall thickness is 0.8mm all the way along the length. 0.4mm. The difference in diameter is 0.8. The wall thickness therefore is 0.4mm, which is quite thin. So that should help in any heat that does find its way into the heat break will get conducted away into the cooler block a lot better than having kind of 1mm wall thickness. That's the idea behind it. And then because the holes in the cooler block are 5mm instead of 6mm, then I've been able to increase the holes in the cooler block for the water flow, so there'll be a higher flow of water through the cooler block, but at the same time it's more compact than the 6 input one. And then finally I've added 3 layers of 1mm thick ceramic fibre insulation on top of the hot part, which will reduce or eliminate any heat that gets radiated from the hot part, because that was kind of happening before. I mean, I didn't have any problem with filament blockages in the heat break or anything like that, but all these things will make it more efficient, so we'll have a much steeper gradient between hot and cold. That's the plan. So as before, the heater and thermistors slide in from the side, and then there's a small screw which retains them and stops them sliding out either side. So they're a nice slide. Those are rimmed 6mm holes, a rimmed 6mm hole and a 3mm hole, so the sensor and the heat will slide in nicely. But I also assemble them with boron nitride paste. I also use boron nitride paste on the heat breaks where where the cooler block slides over the heat breaks. There's boron nitride paste to take up any gap there. So it's 3 metals. It's hot part is brass. The plate that takes the heat breaks is stainless steel. The heat breaks themselves are stainless steel, and then the cooler block is aluminium. And I've ordered some Capricorn XS tubing to line the heat brakes with, so that should enable me to print up to about 250 degrees C without anything nasty happening. I mean, I keep the garage well ventilated when I'm printing anyway, so I should be able to print ASA and ABS and things like that without any problem as well. Still got all the other hot ends that I've made, so I've still got the 6 input multi-material hot end, so if I do need to print high temperature filaments I can just bung that one on, and so we'll see how that goes. What I will do is what I always do, I have a 1mm diameter nozzle, one that I've drilled out, which after I've made these things I generally fit that and then extrude a load of filament, because there could always be some swarf or debris inside, and that will just push it all through before I fit a 0.5mm nozzle or something like that. So I'll fit that once the Capricorn tubing arrives, and we'll give that a go and see what that's like. So yeah, thanks for watching, and until next time.